Hello students, good afternoon. How are you? Jay, good afternoon. Mino Taku, good afternoon. Please give the confirmation about audio and video. All are okay or not? Shubham Kumar Shukla, good afternoon. Everything is fine. Okay. Ashik Sani, good afternoon. All okay. Gokulam, oh, clear. Thank you. Done. All clear. Okay. Okay. Fine. Good afternoon. Done. So here, welcome you all in the Gatewala English channel. Here, this is the session for that revision through previous year questions, and here we are doing the question practice of the previous year questions in the computer network subject. So this is the CN revision session with question practice. So here we have to cover not all the previous year questions, whatever the previous year questions we will cover in the 2 to 5 sessions then accordingly. And evening we have another session, that is the Mahabhyas session, in which I'll cover the questions which is created by me. So here I'll cover the questions. Those are previous year GATE computer science questions. So let's start the session. 𝐂𝐤𝐧𝐤𝐬, good afternoon. Jay is telling your CN is completely depend on me. No any issue. And all the basics and average question definitely you can cover. For the difficult category question, you have to practice. You have to practice little bit about and then make the perfection accordingly. So Pinky, good noon. Then Shashank Bansi, Radhe, Radhe. Then this is a Gatewala English channel. So the audience is basically mostly those who are preferred to learn in the English only. That's why I am covering this session only in English part language. So not in English. The other channels like Gatewala CSE, that is the English channel, Hindi and English combined. So right with UK, that name is Vansh, I think. So good afternoon. Then okay, let's continue the session. So this is a computer network and revision through PYQ, and let me save this first. So we will continue and doing the question practice then. So let's continue revision through PYQ sessions, and then this is the topics we are going to cover today. The same we have covered in the previous session, that is a Maha revision. In Maha revision we have covered all the topics, gone through as a single shot, one shot. We have covered all the important formulas, concept, and that's a quick revision. Yesterday we have not considered the question practice, because if we will cover the questions, then it's become difficult, because we have taken something 9.5 hour session. So it will completed at the end 1:30 at the midnight, and then so we will try to cover the questions on this topic in this session. So let's continue with the introduction. Here I forget to keep the introduction slide. No any issue. QR code is missing. I'll forget to keep here. Then no any issue. You can cover from the previous session. Then so good afternoon. Rupesh Mishra sir solved some good questions from TCP UDP. Definitely, but here we are going to cover the GATE questions only. Here we are going to cover the GATE questions only. So this is the first question, and that is the GATE 2012 IIT Delhi questions. And yesterday we have covered this question. So here poll is there, single choice question, MCQ is there. I am giving 45 seconds to give the answer of this question. Have you seen the poll is visible to you? I think if you are going to join through PW app, then maybe the app is poll is visible to you. I think in the PW app the poll is visible to you. So we are going to check this question. The question is 2012 IIT Delhi question. It is saying that 1 mark MCQ. It is saying that protocol data unit PDU for application layer in the internet stack is. So yesterday we have seen the all the layers protocol data unit is. So no any issue. Harshit Gehlot, if you are not able to see the poll, then you can give the answer over the chat. I'll check how many are in the participated in the poll. Accordingly, I'll decide whether chat is comfortable or this both. So here the application layer PDU is what? The application layer PDU is message. This is the answer of question. Application layer PDU is message. The correct answer of this question is C. So two processes are doing communication by exchanging the messages. The correct statement is that two processes are doing communication. Two processes belongs to different machine. Two processes belongs to different machine doing communication by exchanging messages. By exchanging messages. So correct answer of this question is C. So how many people are participating in the poll? 3-4 people are there. And then Gokulam, Meenotaku, Vivek, Harshit, Gehlot, Ashikani, Logical Learner, Arpit Kumar, Kavya Bhatt. So are you able to see the poll in the YouTube, or you are participating in the poll through PW app? I'm not able to see the poll here. Is it working? Through YouTube. Okay, fine. Then basically it is showing the name of the people also. Fine. So these are the people who have given the answer C. Then this answer of the question is C. If you miss the poll, if poll is not showing in your device, then you can give the answer over the YouTube comments also. Then fine. So here what about the others? Segment, datagram, frame. So here the table is there. Here it is a table. So for transport layer, PDU is what? Segment. Question comes in future, then transport layer PDU is segment. What is network layer PDU? That is datagram. Network layer PDU is datagram. What is data link layer PDU? That is frame. We have already discussed in the yesterday's session, but still I am making one more table for you. Then, so Ravi Shinde is asking poll आता कहाँ है? YouTube. I am also looking because YouTube session is also logged in here, but I am not able to see the poll here. Let's see. Then, so this is the table. Okay, fine. The answer is C. Now come to the next question. The next question is again 2012 IIT Delhi question. So this is a very good question. I am giving 60 seconds to answer this question. Think and give the answer carefully. MCQ. Yes. So we are going to check this 2012 IIT Delhi question. Then Few comments are I am getting here AC. Okay, let's check. It is saying that which of the following transport layer protocol is used to support electronic mail. So tell me one thing, what it is asking. It is asking about application layer protocol or it is asking about transport layer protocol. It is asking about transport layer protocol. What are the transport layer protocol here? Only two, TCP and UDP. Only two transport layer protocol are here, but it is asking about to support electronic mail. Regarding the electronic mail, we are using two protocol. One is SMTP and other one is IMAP. The older version of IMAP is POP. Two protocol we are using to support electronic mail. So IMAP and POP is not given here. SMTP is given. So few people is thinking SMTP is the full form of SMTP is that simple mail transfer protocol. So by assuming that most of the people is giving answer A. At the time in 2012, I repeated the GATE exam because in 2011 I got 200 plus rank. So I was thinking to repeat the GATE exam and I got to 105 rank in 2012. But while giving the exam, initially I decided to give answer SMTP. But I am doing the rereading, again reading the question one more time. While reading this, I got to know that there is a transport layer. If I will not read the question again, then I'll take the SMTP for this question. So the mistake is also doing by me in the first attempt, but in second attempt, I recognize that the application layer protocol is not asking, transport layer protocol is asking. So whenever some question is looking very easy, the one thing is in me, whenever I am finding when a question is very easy, I'll take it challenge and find out that there is some issue, some problem with this question because question can never be easy. There is some trick, some fundamental concepts are there. So I read the question again and then I got to know that the answer is not SMTP, answer is TCP. So the SMTP is given, TCP is given. Here you will find out that the application layer protocol SMTP uses TCP as a transport protocol. If we will talk about IMAP or POP, that is also uses TCP as transport protocol and TCP uses IP as network protocol. TCP uses IP as network protocol. So this is the correct answer of this question is not SMTP. The correct answer of this question is C, TCP, because transport layer protocol is asked in the question. So the correct answer of this question is C. Most of the people have given the answer A. Not most of them, few of them are given answer A, few of them given answer C. So those who are given answer A, read the question very carefully. Sometimes question is looking easy, but it's not completely easy. It's sometimes having a tricky questions like this. 25% people have given the answer C and the 75% people have given the answer A as expected. So I told that I was repeating the GATE exam and then I was giving first attempt answer A, but suddenly I changed my answer and become it C. So here these three people have given the answer C, Kavya Bhatt, logical learner, and Sonu Mahanti. Okay. What about remaining? Remaining people have given the answer A. So please rectify your mistake. Clear? So here I have written the statement for you that what happened. And this is the question. Sorry. This is the first question. This is the second question. And this is the statement for you. What statement is written here? The statement is that so what statement is written here? That is helpful for you. SMTP uses so what statement is written here? SMTP uses email uses SMTP as application layer protocol and SMTP uses TCP as a transport layer protocol. This picture is signifying that thing. Okay. So and then type the Deeptansh Verma is telling type the correct option and it will be recorded. Okay. So the poll is not showing in the YouTube. Basically your comment section is behaving like a poll, right? So you are writing the correct option. Okay, fine. So come to the third question. This one, 2013 IIT Bombay. 2013 IIT Bombay, sorry, 2013 IIT Bombay 1 mark MCQ question. I am giving again 60 seconds to solve this question. 60 seconds is sufficient for this question. And sorry, one second. Here I forget to write the correct options. I copy paste the previous options. Let me correct it. How many times each packet has to visit network layer and data link layer transmission from S to D? So the network layer 4 times, data link layer 4 times. Again the network layer 2 times, data link layer 4 times, then network layer 4 times and data link layer 6 times, and network layer 2 times and data link layer 6 times. Might be something options like this. I forget to type the options here. I copy paste the previous options because I didn't get the time to make the PPT correctly in yesterday night. Done. So here the poll I am going to start right now. So I stop this poll, but what is the option? So here what should I do? I'll make a poll again. I'll make the poll again. So 30 seconds I am giving, and give the answer. What your answer? So here in this question, we will read the question first. Assume that source S and destination D are connected through 2 intermediate routers labeled R. Determine how many times each packet has to visit the network layer and the data link layer during a transmission from S to D. So during transmission from S to D, how many times network layer and how many times data link layer visit the packet? The packet visit the network layer and data link layer how many times? It is asking in the question. Options I have typed accordingly. Might be differ from the gate questions on options, but correct answer is there. So here you can see in this picture there is a 2 process P1 and P2 belongs to 2 different machine S and D. 2 process belong to 2 different machine S and D. P1 is doing communication with process P2. It's the application process. So here the P1 is giving message. P1 is giving message to transport layer and saying that give this message to P2. P1 is giving message to transport layer and saying that give this message to P2. Send this message to P2 means that deliver this message to P2. Transport layer say okay boss, I'll do that. Now the transport layer is converting that message into segment and giving to the network layer and saying that deliver this segment to this transport layer. Deliver this segment to this transport layer. The network layer saying that okay boss, I'll do that. Now the network layer is converting that into datagram. And saying that deliver this datagram to the router's network layer, this router network layer. Why? Because the network layer is doing routing, node to node delivery. So one node to adjacent node to adjacent node, in that way node to node delivery is going on. So this network layer is giving datagram to data link layer and saying that this datagram should be on this network layer. Okay, and the data link layer saying that okay boss, I'll do that. Now the data link layer is giving the datagram by converting the into frame, encapsulating datagram into frame. Basically the concept is that message is encapsulated into segment is encapsulated into datagram, and datagram is encapsulated into frame, and the data link layer is giving frame to physical layer and saying that this frame should be on adjacent, routers data link layer. So physical layer say okay, I'll transmit over this channel. Opposite physical layer catch it and give to data link layer. So physical will transmit, physical will catch, physical will give. This physical is getting the data, it will transmit over the channel, and this physical will collect. What it will transmit over the channel? Bits. Bit by bit transmission is going on. This is collecting the bits, and those bits are basically bits of frame. So it is giving the frame, to data link layer, saying that I have received one frame from the channel. Okay, data link layer find out that whether destination MAC address is mine MAC address. Yes, data link layer find out that destination MAC address is router's MAC address. This frame is for router, so it will remove header and footer from the frame and extract the payload. Remove header and footer from the frame and extract the payload. The payload is containing the datagram. So here the datagram is given to the network layer. Now this network layer find out that datagram is there, and in datagram destination IP address is host D IP address. Destination IP address is host D IP address. It will use its routing table, forwarding table, and find out that who is the next interface. Router is the next interface. So it will find out the router's IP address via next hop, and using the ARP it will find out the MAC address of R. So MAC address is find out by the data link layer. Router is find out, the network layer find out the next hop router IP address and give the packet, give this datagram to data link layer and saying that this datagram should be on this router's network layer. So this network layer is targeting this network layer, and data link layers provide the services. Now this network layer targeting this network layer, and data link layer provide the services. So in this way what happened? The data link layer will find out the MAC address of this router using the ARP protocol and generate a frame, source MAC address, own MAC address, destination MAC address, router MAC address, and convert the datagram into frame. And it is giving the frame to this physical layer. So this router is having multiple physical layer corresponding to their ports. So this physical layer will transmit the channel over this link. This physical will transmit the bits over the channel. This physical will catch. And convert into frame and give to data link layer. And this data link layer find out that destination MAC address is mine MAC address. This frame is for me. Extract the IP datagram from the payload and give to network layer. So it is giving the datagram to the network layer. Remember, the same datagram is here, same datagram is here, same datagram. Datagram is not going to change. Address is not going to change in datagram, and datagram is containing source IP address S and destination IP address D. And datagram is containing IP address, source and destination. But frame is going to change every time. So and it is find out that the destination IP address is D IP address. It's the adjacent host. So it will deliver the packet. It will give the packet to data link here and saying that on this IP address we have to deliver this host D IP address, and this will call ARP and find out the MAC address of host D. Once the MAC address of host D is find out, it will convert datagram into frame. And the frame is given to this physical layer to transmit over this channel. This physical layer will transmit and this physical layer will receive. Now this physical layer will give the frame to data link layer. And data link layer is saying that what? Data link layer is saying that the destination MAC address is mine MAC address. This frame is for me. Okay, I'll remove header and footer and extract the datagram, give to network layer. Once the datagram given to network layer, once the datagram given to network layer, then so here the datagram is given to network layer, then network layer find out that destination IP address is mine IP address, destination IP address is mine IP address, then so in that case the it will accept the datagram and it will remove the header, and in the payload extracted the segment, in the payload extracted the segment, and then once the segment reaches here, the transport layer saying that I have to deal with the port number, destination port number, it will determine the process, it will determine the socket, and based on destination port number it will determine the socket and give the message where the message is present. The message is present in the payload of the segment. It will deliver the message to process 2. So basically message is delivered from P1 to P2 with the help of all the process. But who is responsible? Transport layer is responsible. And then this transport to this transport, data is moving with the help of network layer, and this network layer to that network layer definitely by routing process. So here only one message in one segment in one datagram. Here datagram, all datagram are same. No, nothing is changed. Means only TTL is changed, header checksum is changed, like that. But IP address is not going to change. In datagram, here datagram is source IP address, S IP address, destination IP address, T IP address. The thing is that the multiple frames are generated here. This frame is frame number 1. Here I am writing. This frame is frame number 1. Frame number 1 is arrived here, and once this data link layer remove the frame, means header and footer, extracted the payload and give the datagram to network layer. The network layer is saying to data link layer, make the another frame. This is frame number 2. And this frame number is 2 is destroyed here. Frame number 3 is generated here. So datagram, same datagram is traveling in multiple frame. Same datagram is traveling in multiple frame. Go to hell. One person name is there. He is telling that he or she do not know. He is asking about Telegram link. I forget to keep the QR code. Don't worry. At the end, I'll show the QR code. I'll show the link. I am having. I'll write. My name is. You can find out over the Telegram. Abhishek sir PW. You can find out my Telegram channel. Done. So here in the frame 1, frame 2, frame 3. So our datagram is traveling over the multiple frame. 1 frame, 2 frame, 3 frame. Is it clear? So now the question is asking about that. How many times network layer packet visited? 1, 2, 3, 4. 4 times. How many times packet visited the datagram, data link layer? Here it is asking that how many times each packet has to visit the network layer and data link layer during a transmission. So network layer appears 4 times. Data link layer appears how many times? 1, 2, 3, 4, 5, 6. 6 times data link layer means in every router data link layer appears 2 times. In every router data link layer appears 2 times. 2 router 2 into 2 4. 2 host 4 plus 2 6. So correct answer of this question is that network layer 4 times, data link layer 6 times. The correct answer of this question is C. Is it clear? The complete picture is clear. Complete picture is clear. But sir, PDF, I am not getting what you are asking about Vanch. Okay, so the correct answer is C. Is chosen by all the peoples. 70 students answered the correctly. Surinder Kumar, Hemant, Preeti Mishra, Meenotaku, Deeptanshu Verma, Ride with UK, Alien AJ, Logical Learner, Arpit Kumar, Kavya Bhatt, Shashank Bansi, Raj Yash, Keshri, DK Dharmendra, Nilesh Vikas, Harshit and Pratik. So 17 people are there. I think it is not showing top 10. It is showing name of all the correct answers given by the people. All the people's name who are giving the correct answer. It's difficult to read all the names every time. Then I'll show and then रवि शिंदे बोल रहे हैं सर बुरा मत मानना, फर्स्ट टाइम आई एम सीइंग यू टू टीच इन इंग्लिश, I am also feeling very odd because I am not comfortable to teach in English, but unfortunately I have to do that because I have taken so many classes in the South India also, in Bangalore, in Hyderabad, Visakhapatnam, Vizag. Visakhapatnam is Vizag, that Vijayawada. So I also comfortable to teach, but I am mostly comfortable with English. Then, so no, it's not like that. Those people are not understand Hindi. They are only comfortable with English only. Then, so come to the next question. So is this picture is clear? Here I have shown everything. Frame is also shown that. So in frame, source MAC address this, destination MAC address is this. In this frame, source MAC address is this, destination MAC address is this. In this frame, source MAC address is this, destination MAC address is this. So only frame is going to change. Datagram is not going to change. Same datagram is changing the frame. Same datagram is changing the frame. It's like that you have to traveling and then multiple trains you have to pick. One train, then leave the train, second train you have boarded, then leave the train, then third train you are boarded, and then reach the destination like that. So okay, then so come to the next question. This is the 2022. In 22 IIT Kharagpur, है ना? So DNS questions is there. In very easy questions are there. Yeah, this is the question, and I am giving how many time it requires. 60 seconds is sufficient to give the answer. And read the question carefully and give the answer. So in this question, it is asking that consider the, this is 2022 1 mark numerical answer type question. Consider the resolution of domain name. This is the domain name given in this question. So domain name is given in the question. www.gate.org.in and then by a DNS resolver. So domain name resolution is process is going on by the DNS resolver. Assume that no resource records are cached anywhere across the DNS server. Okay, no any resource record or cache means we have to interact with the DNS hierarchy by the DNS resolver. Then the iterative query mechanism is used in the resolution. Iterative query mechanism is used. Okay, the number of DNS query response pair involved in completely resolving the domain name is. So the domain name is given, this one. So first we have to, the picture is showing that the DNS resolver is there. The DNS resolver can be executed by any of the either you or your service provider. Anyone can execute the DNS resolver. So here I am not interested where the DNS resolver is running, in your machine or in ISP machines, anywhere, but we are talking with respect to DNS resolver. So DNS resolver is making the query to root name server first in the DNS hierarchy. So DNS resolver is making the query to root name server first in the DNS hierarchy. So this is the root name server first, and then root name server is giving the reply to DNS resolver. Why? Because it is operating in iterative mode. Iterative query mechanism is used. So we have contacted according to the DNS hierarchy. So here, this is the query, and this is the DNS reply or response. So we have put the query, we have put this domain name over this query and asked to root name server. Root name server is saying that I do not know where this website is hosted, but I'll give the corresponding server address which is helping you out, which is helping you. So .in. So here .in is a top level domain. So top level domain .in. So it is saying that I'll give you TLD name server which is representing the country specific domain in India. So this name server address is written as a reply. The same query we have to forward to this name server. Same query we have to forward to this name server, and we have forwarded the same query to this name server, and this name server will give reply to us, and this name server will give reply to us. So and this is the query and this is the reply. Same query is forwarded to this www.gate.org.in in saying that I am the TLD for in, but the second top level domain in your URL is org. So I am giving the corresponding top level domain which is representing the org. It's the intermediate top level domain, or you can say second top level domain. So it is giving the address of org top level domain as a reply and saying that ask the same query. It is saying that ask the same query to this. Ask the same query to this. So here the same query is asked to this, and it is saying that okay, you are asking for something, I'll help you out. So here the query, same query is forwarded to this, and it is saying that you are asking for gate. Okay, you are asking for gate. So authoritative name server gate. So it is saying that I'll give you authoritative name server who is representing the gate address. So this is a name server, and this is reply is given by this the second top level domain, and we are going to contact finally this one. We are going to contact finally this one, and this is giving our actual reply. The actual answer we are getting from this. So this query, and this is the reply. It is saying that okay, gate.org.in, the website where this website is hosted, the actual server IP address I'll give, and I am giving as a reply. Now the answer came. So this is the finally last attempt. So here query response, query response, query response, and the last query and response. So here this is what the number of DNS query response pair involved in completely resolving the domain name is. The correct answer of this question is 1, 2, 3, 4. How many query response pair? 4, because it's a 4-tier hierarchy. It's a 4-tier hierarchy: root, TLD, intermediate TLD, and authoritative name server. So it's a 4-tier hierarchy. So answer of this question is 4. So answer of this question is 4. Clear? Some people are giving answer 3. Not 3 is not correct. 3 is for 3-tier hierarchy. 3 is for 3-tier hierarchy. Here intermediate TLD is present. So our answer is not 3. Our answer is 4. So will the answer will always be 4? No, Shashank Rai. It's depend on what is the URL. If your URL is not containing the top, if your URL is not containing the second top level domain, then 3-tier hierarchy. So which tier you are going to contact with the DNS hierarchy? In this hierarchy, how many levels are there? 3, 4, 5. It depend on. So your Shashank Rai, your answer will be depend on domain. If you are saying that www.google.com, answer is 3. If you are saying that www, then this is mygov.in, mygov.in, my.gov.in, or whatever. So you have to check how many level of hierarchy you are going to contact like this. right with UK, it is not maximum is 13. I am telling that 13 is a different types. 13 is a different DNS servers, different DNS hierarchy. 13 types of there. Level is not 13. Level is something sad. I think 127 or something. The number is there. That much level can be there in the DNS hierarchy. We have to talk about URL. Whatever I am teaching, we have to talk with respect to URL. This URL is having ORG, second top level domain. Some URL is not having second top level domain like Amazon.com. Amazon.com is only contacting with the 3-tier hierarchy. So the answer of this question is 4. So 87% people is giving the answer 4, and we have to see the name. These are the name. So 14 people have given the correct answer of this question. I am not reading the names here, and there is a leaderboard concept also. This is a leaderboard which is showing that who is leaderboard means overall all the questions. Till that we have covered 2-3 questions among them. This is the leaderboard. In between time to time we will see the leaderboard. Then come to the next question. Any query with this? Sir, if we don't had ORG, then 6 have been answered. Why 6 have been answered? You are not reading the question. What is the meaning of pair? Do you count pair as a 1 or 2? Pair means 2 is pair of query and response will be counted as a 1. So Akhilesh Yadav, better to give the domain. Na? Let's suppose if I am giving the example, let's suppose your domain is www. Then in this case, how many query response pair? Number of query response pair, that is 3 in the same question. If I change the URL, like this, then answer will be changed 4 to 3. If I make a domain, like that, www.abc.pqr.efg.com. Now tell, and this is 2, then answer is 3. 1, 2, 3, 4. The answer is 5. Root name server, then top level domain, intermediate top level domain, and authority name server. 1, 2, 3, 4. The answer is 5. Clear? Then come to the next. This is 2020. 20 means Delhi, IIT Delhi. IIT Delhi 1 mark numerical answer type question, and good question, not difficult, easy question. So how much time I have to give this question? 90 seconds. Let me save the question first. Now 60 seconds is sufficient. You can read the question and I'll start the poll. 60 seconds. So what is the answer of this question? So what is the answer of this question? So here we have to solve this first. Basically, assume that you have made a request for web page. So you have made the request for web page. Assume that you have made a request for web page through your web browser. Means from our web browser, you have made a request for a web page through our web browser to a web server. Okay, so what is the basically web browser is web client and web server is HTTP server. Basically through our web browser we are making a request for web server, then for a web page. Okay, initially the browser cache is empty, nothing is present in the browser cache. Okay, further the browser is configured to send HTTP request in non-persistent mode. It is given that non-persistent mode. Fine. And the web page contains text and 5 very small images. So the web page contains first text file. So basically HTML file is abbreviated as text file. The HTML file, basically HTML file is a text file. Why? Because you can open it in the notepad. You can see the content in the notepad also. The HTML file is basically a text file, but it is containing the markup language. It is a markup language semi-structured data. You can parse using the braces and shown over the web page with browser like that. So a text file is a basically HTML file, and then 5 small images. The minimum number of TCP connections required to display the web page completely in your browser is. So basically the thing is given here, and the thing is that we have given non-persistent HTTP and non-persistent HTTP. So whenever we are accessing the URL, the URL is always pointing the base HTML file, that is also known as index.html. Once the file is transferred, once the file is received by the client, and then the file is containing reference of images or objects. The file is containing the reference of objects, their URLs on the same server or different server maybe. The thing is that when the HTML file is arrived, then we got to know this web page is containing what? 5 small images object, and we have to load those 5 small images object also. So one by one we have to request to the server, transfer the image 1, then image 2, then image 3 and image 4. But we know that in the non-persistent HTTP, over the one TCP connection, we are not allowed to make request of multiple objects. Only one object is permitted in one TCP connection. So for each object we require separate TCP connection. So here this is the first object, text file. Text file is also an object. So for text file we have to open a TCP connection with the server, make a request for this text file. When this text file arrives, then we got to know 5 different URLs for 5 image objects. Then accordingly we have to one by one open the TCP connection and make a request for objects accordingly. So 1 plus 5, total 6 objects we want from server. Once first object arrive, then we got to know about remaining 5 objects. Total 6 objects we have to request from the server. So how many TCP connection? So in non-persistent HTTP mode, total 6 TCP connection we have required. Total 6 TCP connection we have required. And now some people are saying that can we use parallel TCP connection? Of course, if your machine support, but do not say that I'll use 6 parallel TCP connection. The reason is that first in one TCP connection we have to open a one TCP connection, and then we have to request for the base HTML file. Once the base HTML file is arrived, then we got to know we have to then we got to know the web page is demanding for these 5 number of objects. Then accordingly we can make the 5 parallel TCP connection for 5 different objects. So one TCP connection plus 5 TCP connection. 5 can be in parallel, but you cannot make all 6 in parallel because we do not know that how many objects in the text file. Once the file is arrived, then we got to know about 5 objects. So total 6 TCP connection. Either you can make it in sequential one by one, or first one TCP connection for base file, then once the base file is arrived, then you can open 5 parallel TCP connection. Anything can be possible, but total number of TCP connections is 6. Total number of TCP connection is 6. So any doubt in this question? Any doubt in this question? So total number of TCP connection we have to require as per the non-persistent HTTP is 6. So 73% people have given the answer. These are the people: Deeptansh, Jyotiradit, Akhilesh, Jay, Meenotaku, DK, Dharmendra, Vikas, Gokulam, Pratik, Livanchi, and Arpit. If persistent is there, then how many number of TCP connection? 1. If persistent is given, then answer is 1. But in persistent answer is 1, but definitely those objects should be on same server. Definitely those objects should be on same server, because if we have established a TCP connection and then we have retrieved that base HTML file, and the HTML file is giving reference for 5 small images object. If 5 small image object is present in the same server, not in different server, in same server, then in persistent HTTP, one TCP connection is sufficient to retrieve all the objects. You can use pipeline, not pipeline, everything is possible. But the problem is that if these images are present in different server, so in case of non-persistent, no any issue. We are making the separate TCP connection for every object. So if objects are present in different server, still our answer is same, 6. But in case of persistent, answer is 1 only when all the objects are present in the same server. Is it clear? So 6 is the answer of this question. Let's move to the next question. This is the 2014 IIT Kharagpur questions. Already we have solved in the batches, but here PYQ sessions are there. So I'll give you 90 seconds to solve this question. MCQ question is here. This is the MCQ question. Okay, so here Deeptansh Verma is asking, sir, so 6 is for persistent if different server for all. Yes, if the all objects, if these are present in different server, this is in server 1, these 5 are in different server, then in case of persistent we have to open separate TCP connection for all, because one TCP connection with one server, one TCP connection with one server. So like that, I'll note it down, I'll make the question over this concept next year. Then what is 6 RTT persistent? Then so come to the concept here. A graphical HTML browser resident at, this is the 2014 2-mark MCQ question. A graphical HTML browser resident at network client machine Q access a static HTML web page from a HTTP server S. So a client machine Q is accessing a web page which is hosted in the web server S, and then the static HTML web page has exactly one static embedded image which is also at S, means the image is also present in the server S. So the web page is referring a image object, and the image object is present in the same server. It is mentioning in the question. Same, the image is also present in the server S. Assume no caching. Which one of the following is correct about HTML web page loading? Which is correct about HTML web page loading, including the embedded image? Embedded image means referred. The image is referred in this web page. The web page is containing the image. Whenever we are loading some web pages, you will find out that web page is loaded, but one box is empty, 2 boxes is empty, 3 boxes is empty. Suddenly you will find out that those boxes are filled with the images. Might be possible that text file is coming, HTML file is already arrived, and image object is requested, it's on the way. Once the image object is arrived, we will load the object and show on the web page completely, like that. So here Q needs to send at least 2 HTTP requests to S. True. If base HTML file and one image object, then we have to make 2 HTTP requests. One HTTP request for base HTML file. Once the base HTML file is arrived, then we got to know this file is having reference of the image object. Then we have to make the request for HTTP. We have to make the HTTP request for image object. Each necessarily in separate TCP connection to server S. Each necessarily in separate TCP connection to server S. This is true when non-persistent HTTP is given. This is true when non-persistent HTTP. In case of non-persistent HTTP, this statement is correct, because in non-persistent HTTP, separate HTTP request in separate TCP connection. Okay. Q needs to send at least 2 HTTP requests to S. True. 2 object, 2 HTTP request, but a single TCP connection to serve S is sufficient. See here, is the image object present in the same server? Yes, the image object present in the same server. Can we do it in single TCP connection? Yes, this is true for persistent HTTP. This is true for persistent HTTP. This is true for persistent HTTP. So this is true for persistent HTTP. So Deeptansh Verma, basically we have to open a TCP connection first. Without opening a TCP connection, how we can do that? So then here the single HTTP request from Q to S is sufficient. Wrong. Why? Because if two objects are there, then two HTTP requests, three objects, three HTTP requests, then not allowed to make a single HTTP request for multiple objects, not allowed. Single HTTP request from Q to S is sufficient. Wrong. Only A and B is okay, looks okay. But if this question is multiple select question, then accordingly, as per the what, non-persistent, this statement is correct. As per the persistent, this statement is correct. But this question is not multiple select question. This question is multiple choice question, and we have to give the best option according to it. So when the image object is present in the same server, then why you are going to open a multiple TCP connection? Make a single TCP connection and request the object accordingly. The better option is looks like that, option B. Option B is looking better over option A. So if you have choice for both the protocol, persistent, non-persistent, then better to use with the persistent. Better to go with the persistent. Better to go with the persistent. Then correct answer of this question is B. So 80% people have given the answer B. Shashank, Libansi, Deeptansh, Shubham, DK, Dharmendra, Alinj, Align, Shashank and Pratik. Leaderboard I'll show after 3-4 questions. Done. So clear about this question? So B is the correct answer. A is also correct, but better option is looking B over A. Done. Come to the next question. This is the 2016 IISc Bengaluru. Very good and easy question. I'll give the 60 seconds for you for this. So here this question is 2016 IISc Bengaluru question. The same question is repeated by IISc Bengaluru in 2024. In this year you will find out that same question is repeated by IISc Bengaluru 2024. Then 1 mark MCQ. Identify correct sequence in which following packets are transmitted. Identify correct sequence in which following packets are transmitted on the network by host, on the network by a host when a browser is requested a web page from a remote server, assuming that the host has been started. Just been started means the browser cache is empty. Restarted means browser cache is empty. Very first what we will do, we have to make a request for web page, but we do not know where this web page is hosted. We do not know where this web page is hosted. So whenever this question is mostly asked in the interview, this question is mostly asked in the interview. The interviewer is asked, you want to open a website www.google.com. Then let's suppose your computer is just restarted, and then www.google.com you have entered in the address bar, and then entered the URL, fire the URL. What happened? What happened first? So you have to tell that initially our browser is not knowing that where the google.com is hosted. So first we have to got to know the web server IP address where the google.com is hosted. So we require to access the DNS. DNS is providing help to get the answer of the where the google.com is hosted. So see, for very first DNS query is raised. So DNS query is fired to, obviously might be your DNS hierarchy or local DNS server, anything, but DNS query is fired, and accordingly DNS reply is coming. Accordingly DNS reply is coming. So accordingly DNS reply is coming, and then once the DNS replies came and we got to know the IP address, we got to know the IP address of where the website is hosted, then we have to make the TCP connection. Let's suppose web server is using HTTP protocol, so TCP is there. So TCP sync packet we have to send. TCP sync packet we have to send, and when we are sending the TCP sync packet, TCP sync plus acknowledgement arrive. TCP sync plus acknowledgement is arrived, and once the TCP sync plus acknowledgement is arrived, at very third we have to make a HTTP GET request for that particular object base HTML file, index HTML file. So HTTP GET request for index HTML file, base HTML file, and then the base HTML file is transferred. The base HTML file is transferred from the server as a response. So HTTP response followed by base HTML file. HTTP response followed by base HTML file. This is the sequence. So we have to fire a DNS query to know about the web server IP address. Once the web server IP address got to know, we have to open a TCP connection, sync packet, server is sending sync plus acknowledgement, then we have to send the acknowledgement along with the HTTP request, GET request for base HTML file, server is giving response, HTTP response followed by the index HTML file. Then this is the correct answer. So first we have to fire a DNS query. DNS query. This is wrong, this is wrong. A and D is wrong. Apart from DNS query, we have to open a TCP connection first. TCP sync packet and then HTTP GET request. This is wrong. Correct answer of this question is C. Correct answer of this question is C. Whenever such question asked in the interview, you can give the answer. This sequence is, whole sequence is written here. So here the answer is C of this question. DNS query first is transmitted from our machine. Whatever the reply came, it is not asking. Whatever the gone, it is asking. Whatever is going, that is asking. And then DNS query, then TCP sync packet is gone, and then HTTP request packet is gone, in that order. So correct answer of this question is C. So 57% people have given the answer C. 35% have given the answer D. TCP first, DNS second, no. So these are the 8 people have given the answer correct this question. Shashank, Akhilesh, Meenu, Taku, Libanshi, Raj, Harshit and Shubham. Dharmendra and Shubham. So is this clear in this question? Concept is clear? The concept is clear or not? Then this, you should remember this thing, because most of the time in interview they are going to ask this question. This is the most favorite and common question for the interview. Most favorite and common question in this with respect to interview. Then they always ask, you are going to open a website, what is the sequence of protocol, what are the sequence of packets is transmitted in your machine, like that. So you have to explain this sequence. And then come to the next question. This is the last question in application layer category. 2016 ISC Bengaluru multiple choice question. Here I am giving the 60 second, 45 second to give the answer of this question. here in this question, it is saying that which of the following is an example of stateful application layer protocol. This is the multiple select question of that era, because in that time, out of 4 options, only 1 option is correct. How they will ask the multiple select question? This is the way to ask the multiple select question. This is the way to ask multiple select question. So here, what about, it is asking about application layer protocol. So identify which is not application layer protocol. TCP is not application layer protocol. TCP is transport layer protocol. Although TCP is stateful, TCP is stateful, but TCP is stateful transport layer protocol. What about 3 protocol? These 3 are application layer protocol. Now in this case, HTTP is stateless. And this is stateful. And then FTP is stateful. POP is stateful. So you can see this table. By seeing this table, you can give the answer. Here, transport layer protocol, stateless UDP, stateful TCP. These are the maintaining the transport level information. These are maintaining the transport level information. Then here, application layer, stateless is DNS, STTP, SMTP. Stateful, FTP, IMAP. Old version of IMAP is POP. These are the stateful. So here correct answer is 2 and 4. Here correct answer is 2 and 4, because this is stateful, but this is transport layer, not application layer. So correct answer is 2 and 4. The answer is C. Stateful application layer protocol. FTP and POP3. Clear? So do not choose the TCP. Do not choose the TCP. Then correct answer of this question is C, 2 and 4. 41% people have given the answer C. B is given by the 41%, 2 and 3, and D is given by the 4 only. No, FTP, POP. 7 students answered correctly. Deeptansh, Minotaku, Jay, and DK Dharmendra, Harshit, Ram Narayan, and Jyotiradit. Remaining people, I think, chosen the TCP as a stateful. Stateful it is. It is stateful. It is stateful, but not application layer. It's a transport layer. So remember, which layer protocol is asked in the question. First, eliminate those protocols. Those are not belong to that layer. Then talk about the concept which is asking in the question. So then this is the leaderboard. Leaderboard is not showing. 7 people name is showing. Okay. Fine. So come to the next question. Is there any doubt with this question? So you have to remember this. You have to remember this one. You have to remember this one. Clear? So you have to remember this one. So this is, and this is the final conclusion. You have to remember, but remember the layer first, and then remember the state condition, whether stateful or stateless. Then okay, I have to collect the above icon for final leaderboard. I'll check in the next poll. Fine. Harshit Gehlot is asking about HTTPS. HTTPS is secure HTTP. That is stateful. HTTPS is stateful, but that is not in syllabus. HTTPS is basically secure HTTP. It is stateful. The protocol need to maintain the client state. The protocol need to maintain the client state, like a net banking application or whatever the login authentication, whatever the, this protocol need the client, this protocol demand to maintain the client state. Otherwise it working is not, it will not work properly. So to work whether this protocol is work only when we have to maintain the client state properly. Then this is not in our syllabus. HTTPS is not in our syllabus. Then next question in the TCP category. 2004 2004 is IIT Delhi. So here the option 45 seconds I am giving to you. So here in this question it is asking that in a TCP a unique sequence number is assigned to each. Yesterday I told in one session that in TCP sequence number is assigned to each byte. In TCP unique sequence number is assigned to each byte, not a segment. Most of the people is thinking that sequence number is assigned to a segment. Most of the people think that the unique sequence number is assigned to a segment. If unique sequence number is assigned to a segment, then first segment sequence number is 1, second segment sequence number is 2, third segment sequence number is 3, and then 4, like that. But you will find out that segment sequence number are not with respect to in that 1, 2, 3, 4. The segment sequence number is according to their byte number. So in TCP, unique sequence number is assigned to each byte, not word, not message, not segment. The bytes of messages, bytes of messages, and bytes of messages. Each bytes, you can write each bytes of messages. Each byte of messages. The message is basically service data unit. The message is basically service data unit to transport layer. The message is service data unit to transport layer. Yesterday I told that one line to remember one thing. There is a movie, that name is Tare Zameen Pe. The movie tagline is that every child is special. The movie tagline is that every child is special. So the TCP is a movie, and that movie tagline is that every byte is special. TCP is a movie, and that movie tagline is that every byte is special. Then you can remember the unique sequence number is assigned to each and every byte of whatever the message is transmitted to the TCP with respect to corresponding process. So correct answer of this question is A. So 85% people have chooses the answer A, but still 9% people have chooses the answer C. Some people have chooses the answer B, word. So the word is basically comes in the IP datagram, network layer. In IP datagram, word is comes in the picture, offset. In IP datagram, offset is word. Offset is assigning to a word. Sorry, offset is a word number. Word number accordingly to the first word of the payload, like that. But here byte is going on. So answer of this question is 85. Sorry, not 85. A is the answer. 85% people have given the answer. So Raj, Surendra, how many people? 18. Not able to read the all name. These are the people, those who have given the answer A. Clear? So let's move to the next. Yes, every byte is special. Sir, one byte for one website said TCP is a byte stream service. Yes, TCP is a stream socket, stream oriented. Stream means byte stream. Yesterday I written one line in that our slide na. TCP is a byte stream. So TCP is a byte stream protocol. Every byte is identified with a unique number. Then come to the next. This is the 2007 question, and very good question. 2007, and here I am giving you 120 second sufficient to solve this answer? 120 second is sufficient or 90 second? I think 90 second is sufficient. You can read and give the answer accordingly. So here in this question, it is saying that consider a TCP connection in a state where there are no outstanding acknowledgement. Outstanding acknowledgement means the acknowledgement whose the acknowledgement of the byte, acknowledgement of a segment which is already acknowledged, and gone from the transcending buffer. So the outstanding acknowledgement is acknowledgement of a segment which is not present in the sending buffer, which is already acknowledged. So do not focus on this line, ignore this. The sender sends two segment back to back. The sequence number of the first and the second segments are 230 and 290 respectively. So here in this question is saying that a TCP sender is sending two segment. TCP sender is sending two segment back to back, and the sequence number of the segments accordingly. This is the one segment and this is the another segment. Two segment is transmitted back to back. The first segment is carrying the sequence number 230 and the second segment is carrying the sequence number 290 as per the question. So during the TCP connection, two segment is transmitted. The sequence number of the first and second segment are this. Now the first segment was lost. So as per the question, the first segment is not reached, it is lost. What should I do? I have to do the one thing. This one. So the first segment is lost. Okay. So the first segment was lost, but the second segment was received correctly by the receiver. Let X be the amount of data carried in the first segment. So X be the amount of data carried in the first segment. So what is the value of X? The value of X is basically what? 290 minus 230 byte. Why? The reason is that is 60 bytes. The reason is that this first segment is carrying a segment where the first byte number is 230 and the second segment is carrying the byte. The second segment is carrying the bytes in its payload, where the first byte sequence number is 290. So obviously 230 to 289. 230 to 289 are present in the first segment. So the first segment size is what? 60 byte. 230 to 289 is present in the first segment. So this is the 60 byte. Fine. Now it is saying that the first segment was lost, but the second segment was received correctly by the receiver. Let X be the amount of data carried in the first segment in bytes, that is 60. So this option is rejected. B, 60, 60, 60. Fine. Now why be the acknowledgement number sent by the receiver, the value of X and Y in that order are. So remember here what happened. The TCP sender, this is the TCP sender, which is written here, the sequence number of the first and light. So this is TCP A, this is the sender, and this is the TCP receiver. If this segment is received correctly, if this segment reached correctly, then receiver will send the acknowledgement number 290 saying that till byte 289 I have received correctly, and then after it will receive this one. So whatever the byte number present in the first in the payload 290 and the last byte number plus 1. But here we do not know how many bytes in the second segment. We do not know how many bytes in the second segment. But remember, whenever a lower order segment is missing and higher order segment is arrived, whenever a lower order segment is missing and higher order segment is arrived, so immediately the receiver got to know, there is a byte number 230 to 289 is missing. Byte number 230 to 289 is missing, and I have received a byte number 290 onwards. I do not know what is the last number. Then so whenever a higher order bytes arrive at the receiver end, receiver will keep this into the buffer. Into the buffer. There is a provision for selective acknowledgement, but the question is not talking about selective acknowledgement. But apart from selective acknowledgement, whenever higher order bytes receive, irrespective of lower order byte, means lower order byte is missing and higher order bytes is arrived. So the receiver is always sending one acknowledgement. And that acknowledgement is the number which is expected by the receiver. Receiver is always maintaining a number which is knowing as next expected byte, and the next expected byte number in the receiver variables is 230. Receiver is waiting for 230. So the acknowledgement number is sent by the receiver is 230, and it is saying that I am looking for 230. I am waiting for 230. Because the previously thing is that whatever the segment receive here, it is saying that consider a TCP connection in a state where no outsend. The sender send two segment back to back. So here, once the TCP connection is established, then as per the initial sequence number acknowledgement number, the receiver is knowing that the sender will send a byte which is starting with the 230. So the receiver is expecting the sequence number. Once the connection is established using the initial sequence number, both the party is always maintaining the expected sequence number, that is known as next expected byte. Next expected byte is 230. So here it is saying that I am waiting for 230. And 230 is not received. So 230 means 230, it is saying that 230 I am looking for 230. So whenever 230 is arrived here, the sender got to know might be higher order byte is received, lower order byte is missing. So this will be the correct answer of this question. If receiver is sending 290, it means this segment is received. If receiver is sending 290, it means this segment is arrived. So in TCP, acknowledgement is always cumulative. cumulative. So means if a segment 230 to 289 is arrived, the acknowledgement number should be 290, but the segment is not arrived. So do not send acknowledgement number 290, and do not send selective acknowledgement. It is not asking about selective acknowledgement. It is talking about combined or cumulative acknowledgement. So we have to advertise a number 230 and saying that I am expecting for byte number 230. So correct answer of this question is 60 and 230. So correct answer of this question is D. Correct answer of this question is D. So this question is talking about just a mid situation. Whenever some expected byte is missing and higher order byte is arrived, receiver will keep the higher order byte in the buffer, but do not acknowledge this. Do not acknowledge this. Send a expected byte number next byte expected, that is 230. So correct answer of this question is D. 60 and 230. So 13% people have given the answer 13%, and 53% people have given the answer B. Not 230 is not a size. This is containing the size what? This is containing the size 60 byte. The first segment is containing the 60 byte, and some people have given the answer that is A. So 290. If we are sending 290, it is saying that till byte it is 2. If we are sending 290, it means if we are sending 290, it is saying that till byte 289. Till byte 289, everything is clear. Till byte 289, everything is clear. But that particular segment is not received here. So the correct answer of this question is D. Only 2 people have given the correct answer, Shubham and Hemant. Might be, I think I have given the less amount of time to solve this question. Rohit Pratik is asking how to attempt the poll. Rohit, you have to answer over the comment. You have to answer over the comment. The poll is automatically fetching it. You have to write it ABCD like that. So might be, I think I have given the less amount of time to solve this question. So now tell me. The concept is clear or not? The concept is clear or not? Any doubt with this question? Okay, then move ahead. The one more question with respect to TCP 2018 IIT Guwahati numerical answer type. I'll give sufficient amount of time to solve this question. Integer question. 120 seconds is sufficient to solve this question. So here in this question, the thing is that consider a long-lived, this is a 2018 IIT Guwahati question, 2 marks, numerical answer type. Consider a long-lived TCP session with an end-to-end bandwidth is 1 Gbps. A long-lived TCP session with an end-to-end bandwidth is 1 Gbps. That is given 10 to the power 9 bits per second. The session starts with a sequence number 1, 2, 3, 4. The minimum time in seconds rounded to the closest integer before this sequence number can be used again. So basically it is talking about wraparound time, that is also known as maximum segment lifetime. So it is talking about wraparound time, and in TCP sequence number is 32-bit long. Sequence number is 32-bit long. So in TCP sequence number is 32 bits long, and then we have to talk about wraparound time, when the sequence number is going to repeat it as earliest. Minimum time when the sequence number is used again, repeated, that is wraparound time. That is also known as maximum segment lifetime. So it is basically what? How many bytes we can address using 32-bit number, 2 to the power 32 bytes divided by bandwidth. These number of bytes we can address using 32-bit number. How many time it will require to transmit these number of bytes using the given bandwidth if we are transmitting back to back, and assuming that header size is negligible, assuming that header transmission time is negligible, and we are transmitting only payload, byte and byte back to back. Then so here 2 to the power 32, convert that into bit, 2 to the power 35 bits divided by bandwidth is given 10 to the power 9 bits per second. And then we have to use the calculator for solving this. So here the calculator is there. Might be checked whether it is scientific calculator or not. So can I use the power value here? Yes. So here 2 to the power 35 and divide by 10 to the power 9. The answer will be in seconds. Right? So where it is the enter, this is 34.35. 34.35 second, and it is asking that rounded to the closest integer. So our correct answer is 34. So correct answer of this question is 34. Clear? So this is very basic concept. 32-bit sequence number in the TCP by default. 2 to the power 32 bytes is addressed by the 32-bit sequence number. How many time it will take to transmit these number of bytes? After that our sequence number is repeated. Correct answer is 34. 81% people have given the correct answer, that 9 students answered correctly. These Deeptan, Shashank, Shubham, DK Dharmendra, Libanshi, Rohit, Arpit and Priyadarshini Agrawal. Done. So here again still I forget to open the leaderboard. Okay, I'll check in next. Raj is saying that I make it 35. What is written? Rounded to the closest integer. If this value is less than 0.5, 34. If above 2.5 and above, then 35. So choose the options accordingly. Clear? Then okay, let's move to the one more question. This is the 2024 ISC Bengaluru question. Very easy, 1 mark. Remember, this is multiple select question. This is multiple select question. So here I have to give this poll. I am giving 60 seconds to answer this question. So this is the question. It's saying that the client P successfully established a connection. The client P successfully establishes a connection to TCP server Q. Okay, the question is saying that we have client and server P and Q. So here this is the client P, TCP client and server Q. So TCP client P successfully established a connection to TCP server Q, and that is saying that let NP and NQ. Let me clear first. This is sync packet, and sorry, this is the sync plus acknowledgement. Now what the question is saying, let NP denote the sequence number in the sync sent from P to Q. The sync packet sent by the P to Q in which the sequence number is NP. In which sequence number is NP as per the question. Let NP denote the sequence number in the sync sent from P to Q. Okay, the NQ denote the acknowledgement number in sync plus acknowledgement. This is the sync plus acknowledgement. This is the sync plus acknowledgement in which sequence number is something I do not know. In which sequence number is something which is not initial randomly chosen by the queue. So here I am not writing sequence number. Here I am writing acknowledgement number. So acknowledgement number is what? NQ. It is saying that acknowledgement number is NQ. And what is the sequence number? We do not know here. It is saying that the NP denotes the sequence number in the sync sent from P to Q, and NQ denotes the acknowledgement number in the sync plus acknowledgement from Q to P. Which of the following statement is R? Correct. So first we have to tell this NP is chosen randomly by the P. This NP is chosen randomly by the P. And second thing, this NQ is basically what? This NQ is basically NP plus 1. So here you will find out that the acknowledgement number NQ is equal to NP plus 1. True. The acknowledgement number NQ is equal to NP. False. Second, the sequence number NP is always 0 for a new connection. False. 0. Why it is not 0? Whenever connection is not established, then we have to reconnect. At the time of reconnect, the problem is that how server is going to recognize whether you are asking about previous one or newer one. So always we have to choose the random sequence number. Always we have to choose the random sequence number to prevent some kind of attacks also. Then, so A is false, and that the sequence number NP is chosen randomly by P. true. We have to ask correct or incorrect. Correct. Then B and C is the answer of this question. Correct answer of this question B and C. Correct answer of this question is B and C. B and C is the correct answer of this question. Then let's see it is working or not. So leaderboard is saying that 30 students answer correctly. Then Deeptansh, Shashank, Priyadarshini, Akshat, Shubham, Devanshi, Meeno Taku, Raj, Dharmendra, Arpit, Vikas, Ram and Ravi. And I think it is showing the leaderboard. This one. This is the leaderboard till now. Dharmendra and Deeptansh average time it is showing, I think. Student participated 39. So these it is showing all the names which is appeared till date. Okay, this is a complete summary. Fine. Then come to the next question. Okay, most of the people is writing B and C. Very good. So come to the next question. Very easy question. It's not a difficult one. It's a conceptual question. If somebody is knowing about TCP connection establishment three-phase TCP, three-way handshake connection establishment process, then they can able to answer this question. Now come to the next question. This is the IIT Roorkee question. IIT Roorkee is the only who is going to who already asked the question on connection termination in 2017. So this is a TCP connection termination, and then I am giving you sufficient amount of time to solve this question, 120 seconds. Read the question and solve it carefully. This is the MCQ. So this is again a very good question, but generally in IIT the question is not coming on the TCP connection termination phase. In IIT generally questions are not coming in the TCP connection termination phase. That's why people are not studying that part. But in this year the question is asked. So what it is saying that, let me draw TCP client and server. TCP client and then TCP server, and it is saying that consider a TCP client and a TCP server running on a two different machine after completing data transfer, the TCP client calls close to terminate the connection. So as per this statement, TCP client calls close, terminate the connection. So here the close system call, executed by TCP client first, and as per the close system call executed by TCP client, we have to send sync packet. We have to send the FIN segment. We have to send the FIN segment to the server. FIN. The close system call is initiating a FIN segment. FIN bit is on in the TCP flag. So then FIN segment is transmitted by the client as per the question. So the client call close to terminate the connection and the FIN segment is sent to the TCP server. Okay. Now the server side TCP responds by sending an acknowledgement which is received by the client side TCP. So as per this question, the server has sent the acknowledgement. The server is already sent the acknowledgement. The server side TCP is already sent the acknowledgement of this FIN segment. So here if we will talk about state transition diagram. So here I am writing that before that this state is established. Here the state is established. Here after sending FIN segment until acknowledgement is arrived, this state is FIN wait 1. This state is FIN wait 1. Now here the client is waiting for server side FIN all. So now server is sending the FIN segment. Now the server is sending the FIN segment. Server is executing the close. System call. Server is executing the close, and this close is sending the FIN segment. This close is sending the FIN segment from server to client. And okay, fine. This is the FIN. So here the concept is that here the state transition is, this state is FIN wait 2. This state is FIN wait 2. And this state is close wait. We have already discussed in the yesterday session. And then FIN wait 2. Now question is asking, as per the TCP connection state diagram RFC 793. RFC, I already told that request for comment is a research papers collection, standard collections for the computer network. Whoever any person is writing the book, they always giving the reference for RFC. Whatever the quoted in RFC, that is the correct. It is a truth for the computer network point of view. So it is a standard reference 793. Which state does the client side? In which state does the client side TCP connection wait for the FIN from the server side TCP? So the client is waiting for the FIN from server side TCP. Client is in which state? The correct answer of this question is FIN wait 2. The correct answer of this question is FIN wait 2. In this state, the client side TCP is waiting for the server side FIN. The correct answer of this question is D, FIN wait 2. The correct answer of this question is D, FIN wait 2. So 61% people have chooses the answer D. 28% people have chooses the answer C. Fin weight is over. As per the question, already acknowledgement arrived. As per the question, already acknowledgement arrived. Fin weight 1 is over. Fin weight 2 started. Then in which state client side is waiting for its fin segment? Server side fin segment. Fin weight 2. And 28%, 4%. Okay. 13 students are giving the correct answer. These are the people. So these are the people who have given the correct answer of this question. Then, so here I'll complete more state also. What is that? Now here the server is sending. Can I move this? Now here I'll write this is sending the acknowledgement. This is sending the acknowledgement, and this is the acknowledgement packet. Until here the state is last acknowledgement. Till here the state is last acknowledgement, and here the state is time wait. Here the state is time wait. After time wait, it is entered into the close. It is entered into the close. This is the complete picture. Correct answer of this question is fin weight 2. Clear? Then come to the next question. Is there any doubt with this question? Here few people is saying something. What is the statements here? Deeptaj Verma is saying that, sir, my luck is so bad that it can come this time. Why your luck is so bad? If you have not studied this topic, then luck is bad. You already covered this topic. Why you are fearing about it? Then, okay. Fine. Okay. Then come to the next question. This is a socket programming question. 1 mark question, 2008 ISC Bengaluru. Multiple choice question. 45 seconds is sufficient to give the answer of this question. Write the answer. So, see in this question, this is a 2008 question, and that is the 1 mark MCQ. Which of the following system call result in sending the sync packet? Sync packet always sent by the connect system call. Sync packet always sent by the connect system call. If you will talk about the TCP server, TCP server always execute the system call socket, then bind. Socket is creating a new socket, is requesting to OS to create a new socket. Bind is basically assign basically assign a registered port number to a socket. And then listen basically it's a trap, means server is waiting for the client request. Now the TCP client which want to make a request come in the picture. First execute the socket and create a socket in own machine with the help of operating system. So it making the request to OS using the system call, create a socket for me. OS is assigning a dynamic port number, ephemeral port number. No need to assign, no need to give the bind here like earlier. See, directly we have to call the connect. Directly we have to call the connect, and this connect system call is making the sync packet, sending the sync packet. So it is saying that Which of the following system call resulting the sending of sync packet? It is connect. Connect is always executed by the client only. Correct answer of this question is D. Correct answer of this question is D. Sync packet is sent by the client. Very easy question, 1 mark question. Connect. 85% people have given the answer D, 10% people have given the answer B, and 5% is giving the answer C. So listen, is reading the waiting for the sync packet from the client side. But who is sending, who is invoking the sync packet? Connect. Bind is used to assign the name of the socket, means basically we have to use the registered port number like that. So these are the people, 17 student. These are the name of the peoples. 17. Now come to the next question. This is the TCP condition control slow start phase question, and very good question. I am giving the 90 seconds. Read the question carefully and give the answer. So see in this question, consider the following statements regarding the slow start phase of the TCP condition control algorithm. Note that CWND stands for TCP condition window and MSS denotes the maximum segment size. Here in this question, the CWND increases by 2 MSS on every successful acknowledgement. The CWND increases by 2 MSS on every successful acknowledgement. False. In slow start phase, CWND increases by 1 MSS on every successful acknowledgement. Then this statement becomes true. Increases by 1, not 2. CWND approximately doubles on every successful acknowledgement. False. On every successful acknowledgement, window increases by 1. The CWND increases by 1 MSS every round trip time. True. In a round, if let's suppose 4 segment is transmitted in a round and all 4 acknowledgement is arrived, then window is getting double. 4 plus 1, 5 plus 1, 6 plus 1, 7 plus 1. So 4 become 8 at the end. So not directly 8, 4 to 5, 5 to 6, 6 to 7, 7 to 8. In a round, window become double. So this is true. So it is saying that CWND increases by 1 MSS every round trip time. Sorry, wrong. This is not true. This is false. This is false. CWND increases by 1 MSS every round trip time. No, in a round trip time, window get double, not one. This is true for condition avoidance phase. This is true for condition avoidance phase, but question is regarding the slow start phase. So the CWND approximately doubles every round trip time. So then here this is the true and all three are false. Then we have to ask which one of the following is correct. Which one is following is correct? The correct answer is only 4 is true. So the answer of this question is C. Only 4 is true. The answer of this question is C. 62% people have given the answer C. And what about 18% people have given 2 and 3? No, 2 and 3 are false. 1 and 3, both are false. So 62% people have given the answer. These are the names: 10 students: Shubham, Kodmender, Dharmendra, Rohit, Livanshi, Ravi, Shashank, Akshat, Deeptansh and Arpit. So read the statement very carefully. Regarding the slow start phase, the TCP condition window increases by 1 MSS for each individual acknowledgement, and at the end of the round, in one round, window get double, and indirectly we are seeing that the window is growing exponentially. Condition window is growing exponentially. 2 become 4, 4 become 8, 8 become 16, 16 become 32, like that. So here this is the easy question, not a difficult one. 2018 IIT Guwahati. Come to the next question. This is based on TCP condition control 2014 IIT Kharagpur. Numerical answer type question. I am giving 90 seconds or 120 seconds. 120 seconds to solve this question. So here in this question, this is the condition control based numerical. Let the size of the condition window of a TCP connection is 32 kilobyte when a timeout occur. So the condition window we have abbreviated as CWND. So CWND is given in the question, that is 32 kilobyte when timeout occur. The round trip time of the connection is 100 millisecond. So RTT is given in the question, that is 100 millisecond. Apart from that, the maximum segment size is 2 KB. So maximum segment size is 2 KB. So in short, can we convert CWND into kilobyte? Sorry, can we convert CWND from kilobyte to MSS? Yes, divide by 2. So if we will do and divide by 2 KB, so here 32 KB divide by 2 kilobyte. Basically, it is 16 MSS. And as per the question, CWND was 16 MSS when timeout occurred. 16 segment was transmitted, but acknowledgement not arrived and the timeout occurred. So as per the question, timeout state is there. And whenever timeout is occur, what we have to do? Whenever timeout is occur, what we have to do? We have to update the threshold, SS thresh, slow start thresh. So slow start thresh we have to update, that is CWND divided by 2. The CWND is what? 16 MSS divided by 2, that is become 8 MSS. Our current threshold is become 8 MSS. Updated threshold after the timeout is 8 MSS. Now, as per the default TCP condition control, the CWND is become 1 MSS after that. So here I am writing that CWND is become 1 MSS. So CWND is become 1. And then our algorithm is started. Now the question is saying that the time taken in millisecond by the TCP connection to get back to 32 KB condition window is. So whatever the window size when timeout is occur, we have to reach to that limit. Till that, how much time it will take? 32 to 32. When it drop down to 1 MSS, and then we have to reach again to 16 MSS. Then we have to count how many number of rounds it will take. One segment is transmitted. Once the acknowledgement is arrived for one segment, one is less than 8, slow start fails. It becomes 2. When 2 segment is transmitted and all the 2 segment acknowledgement is arrived, first acknowledgement 2 plus 1 3, 3 is less than 8. Second acknowledgement arrived 3 plus 1 4. 2 plus 1 3 plus 1. After getting acknowledgement of all the 2 segments, it becomes 4 MSS. Now 4 segment is transmitted and all 4 acknowledgement is arrived one by one. First acknowledgement 4 plus 1. Second acknowledgement 5 plus 1. Third acknowledgement 6 plus 1. Last acknowledgement 7. 7 is less than 8. 7 plus 1 8. After getting 4 acknowledgement, it becomes 8 MSS. After getting 4 acknowledgement, it becomes 8 MSS. And then it is the 8 MSS. Now in this case, what happened? Our condition avoidance phase started. Why? Because we have touched the threshold limit. And once we have touched the threshold limit, then what happened? 8 segment is transmitted. And when acknowledgement of all 8 segment arrive, then our window become 9 MSS. And in that way, if you will go, there is a one particular round in which 15 segments are transmitted, and when acknowledgement arrives for all 15 segments, then our window becomes 16 MSS. So in the beginning, window was 15 segment is transmitted, and when all the acknowledgements are arrived, then our window is become 16 at the end of the round. So we have to count how many rounds it will take to get back to the 16 MSS. We have to apply the count here. You will find out that after timeout, this will take negligible time to update it. 1, 2, 3, 4, and then in 4 it will become 9. In 5 it will become 10. So here you will find out that 11 to 16 means total 6 more. So this is the 11th round. This is the 11th round. You can count accordingly. So after the timeout, one round window started from 1, ended with 2. So second round started with 2, ended with 4. In the last round, started with 15, ended with 16. So the exact answer of this question is what? Exact answer of this question is 11 into RTT. This amount of time it will take to get back to the 32 KB size. So RTT is given what? 100 MSS, sorry, MS. So it will become 1100 MS. That is the correct answer of this question. But the IIT Kharagpur have given the answer in range. The answer was 1100 to 1300. Why they have given 1300? The reason is that if some people by mistaken counted this round also, although this is not required because timeout occur, whenever timeout occur, timeout always occur at the end of the round. We have transmitted the segment and waiting for acknowledgement. If acknowledgement arrive, that is end of round. Acknowledgement not arrived, we got timeout, that is also end of the round trip time. So it is the end of one round. One round is completed. This question is not here, question is here. It is saying that at some point of time the condition window is 32 KB when timeout occur. Timeout already occurred. Timeout already occurred. So do not count this round. But by mistake, if you are counting this round, your answer will be 1200. And if you are including one more round after that, let's suppose 16 is not going to become exactly in the end of the round. You are saying that acknowledgements are arrive, and then we have to include the next round also. If by mistake you are going to include second round also, like a 12th one, might be your answer can be 1300. So safe and side they are giving the answer on range, but the correct and exact answer of this question is 1100. But they have given the expansion of the range because of if some people is doing cross questioning or blaming them how you can be more strict and giving answer 1100. Might be possible that because here we are giving the answer by assuming some conditions, but in real life situations will be in the scattered fashion like that. In the when first acknowledgement arrives, that is the end of the round trip time, and remaining acknowledgement is counted in the next round trip time. So that's why some confusions are there, that's why they have increased the options. But what I suggest, while giving the answer in the gate, do not do not follow any other assumptions, just follow the strict deadline. In 11th round at the end our window becomes 16, so answer should be 1100. Clear? So because while solving the numerical we have to take certain assumptions, then only we can able to solve the numerical exactly. So 85% people have given the answer 1100, but those who have fill up the answer 1200 and 1300, their answer can also be marked correct with respect to their answer. So here the number of people 6: Rohit, Shashank, Mender, Libanshi, Ravi and Deeptansh. Might be remaining people have given the answer 1200 and 1300, that is also marked as a correct. Then is it clear? So let's move to the next question. Here now we are moving to the IP address. Here we are moving to the IP address. Shashank Rai is asking how to get this concept just by reading about it. So basically you have to read the TCP congestion control algorithm and how to solve the numerical in the exam. So I have covered complete session in the, I think I have covered this part in crash course also. I have covered this part in crash course also. In crash course, full course, everywhere you will find it out. First you have to read the question. First you have to understand the concept. Then only you can able to solve the questions. Then Shubham Kumar Shukla, your answer is not recorded because I think you have given the answer in 1100-1300. You have to give one correct answer, 1100. Then, so here, this is the one question in IPv4 addressing. Very easy question. In 2012, IIT Delhi asked 45 seconds I am giving to solve this question. So in this question, it is saying that in the IPv4 addressing format, the number of networks allowed under class C address is. So regarding the classful IPv4 address in class C, for class C, the network ID is 24-bit. Network ID is 24-bit in size, but for class C, your IP address should start with 110 dash dash dash. So means starting 3-bit is always fixed for class C IPv4 network. So out of 24, 21 bits are allowed to vary, 3-bit are fixed. So number of networks worldwide, number of networks कितने बनेंगे? Number of networks in class C should be 2 to the power 24 minus 3. So this is 2 to the power 21. These are the number of networks. So in IPv4 addressing format, the number of networks allowed under class C address is C. Correct answer of this question is 2 to the power 21. Most of the people is selected 2 to the power 24 by assuming that 24-bit network ID. But the concept is that network ID is 24-bit, but out of 24-bit, we are allowed to vary 21-bit only. 3-bit is fixed, reserved. Correct answer of this question is C. So 89% people have given the answer C. These are the people, 17 students. These are the people who have given the correct answer. Then, is it clear? No any issue? So come to the next question. So if somebody is giving answer B, that is B is correct for B is correct for what? B is correct for class B. B is correct for class B. A is correct for class A. For class A, class B, class C. These are the options. Then come to the next question. Here, this is the very good question. 60 seconds is sufficient to give the answer of this question. 60 seconds. So this is the question is saying that a subnet has been assigned a subnet mask this. What is the maximum number of hosts that can belongs to this subnet? What is the maximum number of hosts that can belong to this subnet? So here subnet mask is given in the question. 255, 255, 255 and 192. So here we have to convert it into 255 binary. Last octet we have to write in the binary only. That is 1160. 60 means how many bit host ID? Host ID is 6 bit long. Host ID is 6 bits long. Then what is the maximum number of sub hosts that can belong to the subnet. So it is then that maximum number of hosts can be in a subnet. That is subnet size. That is what? 2 to the power 6 minus 2 hosts. So it should be 62, I think. Why 62? Out of 64, 2 are special IP address that cannot be belong to a host. Correct answer of this question is C. Correct answer of this question is C, 62. So very good, 100% people have given the correct answer. So these are the name, those who have given the correct answer. 18 people are participating in the poll and given the correct answer. Done. Clear hai? Then come to the next question. This one is also a very good question. 2003 IIT Chennai. MCQ. 90 seconds I am giving to solve this question. So here in this question, it is saying that thus 2003 2 mark MCQ subnet mask for a particular network is this. Which of the following pair of IP address could belong to this network? You can find it out that subnet mask. We have to find out that which of the pair of IP address could belong to this network whose subnet mask is given here. So you can find out that first 2 octet is 255. It means it is true that those IP address belongs to this network whose network mask is given. They have same value in first 2 octet. Here 172.57, 172.56. Wrong. This cannot be belong to the same network. Then 10.35. We have to check 191.203, 191.234. This cannot be belong to same network. 128.8, 128.8. Okay. Last octet we do not need to check. Why? Because it is 0. So it can be anything 62, 223. No any issue. We have to check with what? We have to check with 28 and 29. So here I am writing the binary of 28 and binary of 29. Binary of 28 and binary of 29. Binary of 28 is what? 0, 0, 0, 1, 1, 1, 0, 0. What is the binary of 29? 0, 0, 0, 1 1 1 0 1. Is this 16 8 24? 24 plus 1, that is 20. 24 plus 1, that is, what happened here? Advertisement is showing here. I'm not able to see the comments. Comment is shifted at letter side. Okay. Fine. And then, so here the, what is the third octet in the mask? 31. Although this is the discontinuous mask, should not be used practically, but while writing the question they have used this concept, but they should not use this type of discontinuous mask. Then here the 31 is what? 0 0 0 1 2 3 4 5 0 0 0 1 2 3 4 5. If we are doing bitwise AND, this will determine our answer. Doing bitwise AND, you are getting 0 0 0 1 1 1 0 0, that is 28. Here 0 0 0 1 1 1 0 1, this is given 29. So this is 28, this is 29. Third octet after doing bitwise AND with this mask is not matching. So third octet value is not matching. B cannot be our answer. So who is remain? D. Correct answer of this question is D. Correct answer of this question is D. If do not have time in exam to solve, do not check. If B is rejected, A or C already rejected, D is remain our answer. But if you have time in the exam to cross check, then check about it 129 and 161. Check about it 129 and 161. So 129 and 161. What is the binary of it? This is the binary of 129. This is the binary of 161. And we have to do bitwise AND with 31. We have to do bitwise AND with 31. Here 0 0 0 0 0 0 0 1. And here 0 0 0 0 0 0 0 1. So the D is the correct answer of this question. As per this, which of the following pair of IP address could belong to this network? Only D option is showing that. So D is saying that they belong to the same network. So those who have given the answer B, 57%, B is not a correct answer, D is correct answer. D is correct answer. So A is simply rejected. A is simply rejected, 57 and 56. Second octet should be matched. First two octets should be common for them. First two octets should be common for them. So if you have studied this topic in sufficient way, then you can able to answer this question in very short amount of time. Else it will take long amount of time to answer this question. So only 2 students have given the answer D, Shashank and Code. So I think I have given the 90 seconds to solve this question. It is taking less amount of time to solve this question. Later I am finding out that most of the people is giving answer over here. So is it clear? Here the way I solve this question, very least and optimized way. See, first two octet is 255. Accordingly, I rejected option A, option C. And then B and D are two possible options. I have to check accordingly. I have checked for option B with the third octet, 31, 28, 31, 29. The result is not same, result is different. So come to the next question. This is the 2015 IIT Kanpur question. This is a 2015 IIT Kanpur question. शशांक राय पूछ रहे हैं सर why 172 is not included in 255? Where? This one. See this value. See this value. this is 57 and this is 56. So it should be same. First two octets should be same to become a possible answer. To become a possible answer, first two octets should be same. If you are not understanding this, why first two octets should be same, I have to suggest you have to revise the lecture completely. Then you can able to understand why I am solving this question in shortest way. Clear? So this is the question, and 60 seconds is sufficient to give the answer of this question. So this is the question, 2015, numerical answer type. In the network, this, the fourth octet in decimal of the last IP address of the network which can assign to a host. So here we have to write that whatever the IP address is given, that is 200.10.11.144/27. We have to write the binary of last octet only. The binary of last octet is this /27. It means from here to here. This is the network ID, 27 bit, and this is host ID, 5 bit. As per the question, our answer will be last host IP address, and we have to find about the last octet. Our answer will be 100 is a prefix. We cannot modify it. But the 5-bit host ID should be all 1 minus 1. 1, 2, 3, 4 and 0. If I will fill host ID part with all 1, it will become network directed broadcast address, and the last host IP address should be network directed broadcast address minus 1. This is the answer. This is in binary. If you will find out that this is 158, this is 158, 159 minus 1, 158. So this is 158, 144 plus 14, correct. So correct answer of this question is 158. So I think I have given less amount of time, or some people is given the answer 159 or something else. So this is very easy question, not taking much amount of time. Then 158 is the correct answer. Okay, let's move to the next question. That time कम पड़ गया. Okay, actually the thing is that now I have to complete the session by 5 and few more questions are remain. How many questions are remain? Something 10-12 questions are remain. That's why I am giving less amount of time to solve the question. Okay, no issue. We will cover important ones. Then here, this is the question on routing table. There is sufficient amount of time for 90 seconds to solve this question. Is it? MCQ, and I am giving 90 seconds to solve this question. So in this question is saying that a router uses following routing table. A router uses following routing table. This is given. A packet bearing destination address this arrive at the router. On which interface will it be forwarded? So I told in the previous session, yesterday session, that there is a, you have to pick the destination IP address from the packet, and in the routing table pick the mask that is having highest number of ones. Pick the mask which is having highest number of ones, and this mask is having highest number of ones. Check with this. The first 3 octet is 255. First 3 octet is 255. If we are doing bitwise AND, check first 3 octets is matches or not. 144, 16 and 68. 144, 16 and 68. So first 3 octet is matches. 144, 16 and 68. Okay. The last octet we have to solve 117, and then this is the binary of 224. The 117 is basically what? This is the 112. 112 plus 5. 112 plus 5, and this is 117, I think. 96, 32, 64 plus 32, 96 plus 16, 112, 112 plus 5, 224 is 111,050. Going bitwise AND, it is become 0, 1, 1, 0, 0, 0, 0, 0. This number is 96. And this number is 96, and here the number is 64. So it is not matches. We are not forwarding this packet to Ethernet 3. We are not forwarding this packet to Ethernet 3. Now, as per the longest prefix match, the last mask which is having highest number of ones is not matches. Then we have to pick the mask which is having second highest number of ones. This one. See, 3 octet is 255. Okay. 144, 16, 68. 144, 16, 68. Last octet is 0. Not required. Whatever the value is here, it will always matches. So the correct answer of this question is ETH2. Correct answer of this question is ETH2. The correct answer of this question is C. You can find it out that whatever I am telling that I have written here, you can see in this case, this is the 117 bitwise AND with 224. What is answer we are getting? 96. You can find out that this result is not matches with this destination. So this mask is not giving the correct answer, ETH3. So we will not forward the packet to ETH3. We will forward the packet to ETH2 as per this scenario. So here, this is the answer, C. So it's an easy question. Only calculation is required for this question. So 50% people have given the answer C, and 50% people have given the answer D. So in answer D, you have to find it out that last octet is not matches. Last octet is not matches. Second last octet, sorry, last entry is giving the correct answer. So you will find out that what mistake you are doing. 6 students have given the correct answer: Ravi, Shashank, Jyotiradit, Varun, Harshit, and Code. So have you able to find out that why option D is rejected? Have you able to find out that why option D is rejected? Here the number is 96 is coming after doing bitwise AND. After doing bitwise AND, the number is 96 is coming, and here the number is 64 is present. Then come to the next question. This one. This is the question which will take 60 seconds to solve the question. CIDR aggregation. This question is based on CIDR aggregation. So to solve this type of questions, which one of the following CIDR prefixes exactly represent the range of IP address this to this. So for giving the answer, we have to write the binary of it. Don't need to write the binary of first 2 octet 10, 12. Keep it as it is. Make the binary of last 2 octet 2 and 2.0 3.255. So here I have written the binary of this. This is same binary of this. This is same binary of this. You will find out that this is the 2 and this is the 0. This is the 3 and this is the 255. Here you can see this last 9 bit. This last 9 bit, if we will consider as a host ID, then it is all 0 to all 1. This last 9 bit, if we will consider at, this is a host ID, all 0 to all 1. And this 23 bit prefix is written here. So CIDR prefix will become what? 10.12.000000001. This will be your CIDR prefix, and whatever the remaining part we have to fill with 0, 1, 2, 3, 4, 5, 6, 7, 8. Do not forget to write /23. Do not forget to write /23. Why? Because this is 23-bit prefix. This is 23-bit prefix. So this is 23-bit prefix. So here the answer of this question is whatever the first number is become the network address with respect to 23-bit is a prefix. So the correct CIDR prefixes is what? This. So here you can write 10.12.2.0/23. 10.12.2.0/23. Correct answer of this question is A. Correct answer of this question is A. 10.12.2.0/23. So first number is become the prefix, but slash should be defined. So answer A of this question. 50% people have given the answer A, and 25% have given the answer C, and 25% have given the answer B. So /22 is also wrong. /24 is also wrong. Correct answer of this question is A. I am giving the less amount of time. This question should take 90 seconds to solve, but I am giving the 60 seconds only. So Shashank Bansi and Haritima 3. Shashank Rai is saying that how did we knew 23? Okay, see your concept here. Tell me how many bits are common in between them. Write the binary first. Write the binary first and count that how many bits are common. Prefix. How many prefixes are common between them? So till 23 bits are common. After that, bits are not common. And those bits are not common. Find out that among them is there complete variation, all 0 to all 1 is present or not. Complete variation, all 0 to all 1 present or not. Is it clear, Shashank Rai? So after that, find out that all 0 to all 1 is present or not. So here, this is all 0 to all 1. Total 2 to the power 9 address. Total 2 to the power 9 address represent in this range. Total 2 to the power 9 address represent in this range. Is this clear? Okay. Then the next question. Now come to the MAC address part. This is the question based on MAC address. "60 seconds is sufficient to give the answer of this question. So in this question, you will find out that 2021 IIT Bombay questions is there. Destination MAC address on an ARP reply is broadcast address. Wrong. It should be unicast address. It should be unicast address, means the address of a host who has initiated the ARP query. This is false. Destination MAC address of an ARP reply is a broadcast address. This statement is wrong. Correct statement is that it is a unicast address. Unicast address means whoever the host is initiated the query, broadcasted the query, we have to give the reply to them. Destination MAC address of ARP request is broadcast address. True. Request always broadcast, reply always unicast. Request always broadcast, reply always unicast. So which of the following choices is correct? S1 is false, S2 is correct. So the answer of this question is C. Here we are going to check C is the answer of this question. 100% people have given the answer C. Very good. So these are the people is given the correct answer. Then come to the next question. And this is the 2013 question on fragmentation, and I am giving you the 60 seconds is sufficient to give the answer of this question. So and this is the IIT Bombay question, and again IPv4 datagram, the M bit is 0. M bit is 0, and the question is asking position of the datagram. Position of the datagram should be last fragment. Should be last fragment. It cannot be first fragment. It cannot be middle fragment. It is the last fragment. And it is saying that the value of HLAN is 10. The value of total length is 400. We have to find out the payload size. We have to calculate the payload size. So payload size is basically what? Total length minus HLAN into 4. Do not forget to multiply with 4 because it is in word. We have to convert it is in byte. So the total length is 400 is given in the question. 10 into 4, 40, and the answer is in bytes. So it is 360 bytes. And then it is asking that the fragmentation offset value is 300. The sequence number of the first and last byte of the payload. So offset value is given in this question. Offset value is given in this question, that is in header, that is 300. So sequence number, if we will talk about first byte of the payload, sequence number of the payload, sequence number of the payload so here the first byte number should be offset into 8, 300 into 8. Why? Because 300 is in words and that is in bytes. So it should be 2400. It is 2400 byte. And then most important thing is that last byte number. Last byte of the payload. What you will do? First byte plus payload length minus 1. First byte plus payload length minus 1. That is the answer. That is the 2759 byte. 2759 is a byte number, not byte number. Do not write the byte number here. Bytes is not a correct. So that is the 2400, or that is the then 2400 and 2759. So out of A and C, this is not a correct answer. 2789. Those who are doing mistake, they are not multiplying it by 4. They are getting this answer. And those who are doing correct, multiply it by 4, making word to byte, then they are getting correct answer. The answer is C, 2400 to 2759. The correct answer of this question is C. Correct answer of this question is C. So 100% people have given the correct answer. Very good. Then the next question. Any doubt with this question? No any issue? Okay. And then the next, this one. And again, this question will take 60 seconds to solve. I think ISC Bengaluru. So here, GATE 2016 2-mark network address translation. IP datagram of size 1000 byte arrive at a router. The router has to forward this packet on a link whose MTU is this. Assume that the size of the IP header is 20 byte and the number of fragments that IP datagram will be divided into transmission. So first we have given the 1000 byte datagram arrive at router where header size is 20 byte. We have to calculate old payload size. We have to calculate old payload size. That is what? 100,000 bytes minus 20. 20 is the header size. So total old payload size is 980 bytes. Old payload size is 980 bytes. Then after we have to find out the new payload size. New payload size means the new packet we are going to make as per the MTU. The MTU is given 100. The MTU is given 100. 100 minus 20. The same header size we have to use. The same header size we have to use. So it will become 80 byte. And number of IP fragments we have to form. But before doing division, cross check whether new payload size is multiple of 8 or not. It is multiple of 8. It is in words of 8 byte. Okay. So number of IP fragments, how many it will make? number of IP fragments. So the old payload size divided by new payload size. Do not forget to take seal. Old payload size divided by new payload size. Do not forget to take seal. And 980 divided by 80. Both are unit in bytes. So 980 divided by 80. 12.25. The answer of this question is 13. So the answer of this question is 13. So all people have given the correct answer. And some people are giving answer late because I am giving less amount of time, as I am seeing that while I am solving the question, few people is giving the answer. So it's my limitation. I am giving less amount of time because I have to cover few more questions, and then I have another session at 7. Then so these are the people. Okay, let's check one more question. And this is the question asked by the Roorkee 2017. And 45 seconds is enough to give the answer of this question. So whenever we are using the optional header in IPv4, whenever we are using optional header in IPv4, so in IPv4 options, whenever we are using it, first we have to use option type. It will signify for what purpose we are using it. Let's suppose we are using it for record route. Let's suppose we are using it for record route. And this option type field is 1 byte in size. And whenever we are using for record route, we require option length. We require option length that is also 1 byte. And we also require one more byte, that is pointer. We also require one more byte, that is a pointer. So total 3 byte is necessarily used in the optional header when we are using for record route field. IPv4 optional header maximum can be 40 byte. IPv4 optional header can be maximum 40 byte. Out of 40 byte, 3 byte is occupied by them. How many byte remain? 37 byte. In 37 byte, how many IP address we can write? Obviously, version 4 IP address. One version 4 IP address is 4 byte in size. So out of 37 byte, we can write 9 IP address. 9 into 4, 36. So correct answer of this question is 9. When this question asked in the exam, most of the people is writing answer 10. They forget that the optional header is also having some extra bytes like this option type, option length, pointer. Then we have to start writing the IP addresses in the record route field. So correct answer of this question is 9. Correct answer of this question is 9. So all have given the correct answer. These are the people. Then next, come to the next question. This is a very easy question. This is the question. Can solve accordingly. Previous question is also question. Solve it in 60 seconds. So here, and the one thing you have to remember, routing information protocol uses which routing algorithm? Distance vector routing algorithm. And OSPF is a protocol which uses which routing algorithm? LS. You have to remember this. This protocol uses this algorithm. This protocol uses this algorithm. So here, RIP uses distance vector routing and OSPF uses link state routing. And it is writing that which one of the following is true. True is asking in the question. Only option A is correct. Only option A is correct in this question. RIP DV OSPF LS. You have to remember this line, 2014 IIT Kharagpur. So A is the correct answer of this question. 57% chooses A, 42% chooses B. They got confused. Remember this word, RIP DV OSPF LS. Clear? Then come to the next. So these are the 8 students, those who have participated in this. And one more easy question, this one. 45 seconds to give the answer of this question. Not 45, 30 seconds. Save the time. So everyone is knowing that count to infinity is a problem which is only associated with distance vector routing. Correct answer of this question is B. Very easy question, 1 mark question. Asked in 2005 IIT Bombay. B. All are giving correct answer. So 13 people have given the correct answer. Fine. Now come to the next question. Let me check which one is more important to solve it. And this one. This question, I think 60 seconds is sufficient to give the answer. 60 seconds is sufficient. So here 2008 ISC Bengaluru, two popular routing algorithm, distance vector and LS. Link state. Which of the following are true? Count to infinity is a problem only with DV, not with LS routing. True. This is only with DV, not with LS. True. In LS, the shortest path algorithm is run only at one node. False. In link state, shortest path algorithm, Dijkstra is run in every node, assuming itself as a source. Not only one node, all node. In DV, the shortest path algorithm is run only at one node. False. In DV, we do not need to run shortest path algorithm. The Bellman-Ford equation itself gives a correct optimal output. So no need to run explicitly. Then DV require lesser number of network messages than LS. True. In LS, we need to broadcast the packet. In distance vector, we need to share with the neighbors only. 100% true statement. So S1 and S4 are true, which is asked. True. Okay. S1 and S4 is true. Correct answer of this question is D. S1 and S4 is true. %91% people have given the answer. Then next question. So next question is based on CRC. That is CRC question 2007 IIT Roorkee have asked. I think everyone can solve it. Is there any problem with CRC? If anyone is having query, then you can ask over the Telegram channel. We have to save the time. People can solve it. People can solve it. I am not asking it over the poll. That is a homework. That is the homework we will discuss over the Telegram channel. So if anyone is having query, write the answer over the Telegram channel. Fine. This is the easy question. We can give the answer in 45 seconds. So in this question 2009, again this is the IIT Roorkee question. So Roorkee have asked the question in 2017, in 2009, both the year Roorkee have asked the question on CRC. Let Gx be the generator polynomial used in CRC checking. What is the condition that should be satisfied Gx to detect odd number of bits in error? Odd number of bits in error, that is our second property we have studied in the class, that 1 plus x is the factor of Gx. Why? In such cases Gx should have, in such cases Gx have even number of terms. Even number of terms. And if Gx is having even number of terms, then the error polynomial is having odd number of terms. 100% it is showing incomplete division. Receiver will able to detect the errors. So correct answer of this question is C. Correct answer of this question is C. Everyone is giving correct answer. Very good. Then come to the next question. And next question is and there is a Hamming code. I suggest ki this is the homework question, but remember here after this answer is there, after this slide answer is there. So I'll keep this answer in the notes. You have to solve this question. You have to solve this question and then verify the answer which is written after the next slide. So after this slide, the answer is there in this slide. So do not, I am not showing answer here. And there is a one more question, and this one. This you can solve here. I am giving 90 seconds. Or you can do one thing. This is also I am giving as a homework. This is also I am giving as a homework. Here again, the after this slide answer is there. After this slide answer is there. So you have to solve this question, and after this answer is just present after this slide. So I'll update this slide. I'll update this slide, and then you solve this and check the answer after the next slide. So save the time. This is the question. And this is the question by IIT Roorkee. Very easy question. You can solve it, or better we can do one thing. You can solve and I'll solve in parallel. So one by one we are discussing the thing. So consider two hosts X and Y connected by a single directed link, rate 10 to the power 6 bits per second. The distance between two hosts 10,000 kilometer and propagation speed along the link is 2 into 10 to the power 8 meter per second. Host X send a file of size 50,000 bytes and one large message to host Y continuously. Let the transmission and propagation delays be P millisecond and Q millisecond respectively. Then the values of P and Q are. The values of P and Q are. So here packet size is given this one. Bandwidth is given this one. So if I'll write packet size is 4 into 10 to the power 5 bits divided by 10 to the power 6 bits per second. So you can find it out. We have to get the answer in millisecond. We have to get the answer in millisecond, right? For millisecond, 10 to the power 3 is gone as a second to become millisecond. This is become 400 millisecond. This is become 400 millisecond. And you can find out that the value of P is asking first, and P is 400 millisecond. In no any option is saying that P is 400 millisecond. Correct answer of this question is D. If you want to know the answer of Q also, then the value distance is given this. Signal speed is given this. If you are writing 10 to the power 7 meter divided by 2 into 10 to the power 8 meter per second, then you can find it out. There is a 10 to the power 3 is become millisecond. 10 to the power 100 divided by 2. 100 divided by 2 become 50 millisecond. 50 millisecond. So this is a 50 millisecond. The correct answer of this question is D. Fine. Maximum people is writing D. Then there is a one more question. This one. And this is taking a little bit small amount of time. Or let me check how many more questions remain. Only 2-3 questions are remain. Let me complete it first. And then, so this question is taking, this question is giving that two hosts are connected via a packet switch with 10 to the power 7 bits per second links. Each link has a propagation delay 20 microsecond, and switch begins forwarding a packet 35 microsecond after it receives the same. If the 10,000 bits of the data are to be transmitted between two hosts using a packet size 5,000 bits, the time elapsed between transmission of first bit of data and reception of last bit of data in microsecond. This is a basically packet switch network, and then what we will do? Here, the first we have to find out the packet size is 5000 bits is given in the question. That is this. Bandwidth is given in the question, this one. What is the time required to transmit a one frame? Packet size divided by bandwidth. Packet size divided by bandwidth. The bandwidth is 10 to the power 7 bits per second. Remember one thing, in the question, propagation delay is given 20 microsecond and then processing delay is given 35 microsecond. So we have to convert this in microsecond. This is become 500 microsecond. This is 500 microsecond. 2015 IIT Kanpur. And then here the file size is given 10,000 bits. Packet size is given 5000 bits. How many number of packets? File size divided by packet size. 10,000 bits divided by 5000 bits. Number of packets is 2. 2 packets are there. And end-to-end delay, which is total time. End-to-end delay is basically our total time to deliver the file completely from sending host to receiving host. Here the equation is that n into tx plus tp, processing delay, and tx plus tp. So we have to multiply n in the first tx only. Apart from that, no need to multiply n anywhere else. So here the n is 2, tx is 500 microsecond, tp is 20 microsecond, processing delay 35 microsecond, tx is 500 microsecond, tp is 20 microsecond. Everything is in microsecond. If we are going to add 500 into 3, 1500 plus 20 plus 20, 40 plus 30, 75, 1575 microsecond. This is the answer of this question. This is also an easy question. You can solve it. Same variety of questions you can find in GATE previous year. Very most number of questions are there. And this is a time consuming question. This is the easy question. This is the easy question. Give the answer in 45 seconds. Give the answer in 30 seconds is sufficient to give the answer of this question. So in this question, it is saying that n stations in a slotted LAN, and then each attempt to transmit with a probability p, and then what is the probability that only one station transmit in a given time slot. So only one can be anyone. Only one can be anyone. So if particular one is given in the question, then our answer will become C. If particular one is given in the question, then our answer will become C. But here only one is given, any one is given in the question, then our answer is not C, our answer is A. We have to add the throughput of all the hosts, then our answer is become A. If you are getting confusion over this question, you have to understand binomial distribution probability, binomial distribution. So the correct answer of this question is A. So 66% have given the answer A and 33 have given the answer C. And then one more last question. That is a CSMA CD question. So you can also able to solve it. What it is saying that a network with CSMA CD protocol in the MAC layer is running at 1 Gbps over a 1 kilometer cable with no repeaters. The signal speed in the cable is 2 into 10 to the power 8 meter per second. The minimum frame size for this network should be. Regarding the CSMA CD, we have to use Tx greater than equal to 2 TP. And now if we will talk about minimum frame size, the minimum frame size should be equal to 2 into TP into bandwidth. Then 2 into distance is given in the question, that is what? 1 kilometer. 1 kilometer means 10 to the power 3 meter. Divide by signal speed. Signal speed is given 2 into 10 to the power 8 meter per second. And the bandwidth. Bandwidth is given in the question 1 Gbps. 1 Gbps means 10 to the power 9 bits per second. You will find out that bits and bits get cancelled. No, sorry, 10 to the power 9 and 10 to the power 8. So here 10 become, second and second get cancelled, and 2 and 2 cancel. It is become 10 to the power 4 bits. That is 10,000 bits. The correct answer of this question is 10,000 bits. And the last question I kept here regarding the bit stuffing. So in bit stuffing, there is a question asked in 2014 by IIT Kharagpur. So it is saying that the stuff bit pattern, it is saying that the stuff bit pattern is given 0, 6, 1, 0 in the question. This is 8-bit delimiter stuff bit pattern. So this one. Now output bit. So output is given in the question, that is 0, 1, 2, 3, 4, 5 and 0, 0, 1, 0, 1. And it is asking that what is input. It is asking that what is input. We know that transmitter always stuff a 0 bit after 5 continuous 1. Transmitter always stuff a 0 bit after 5 continuous 1, and receiver always discard it. So receiver will find out that 1, 2, 3, 4, 5. After 5, 1, whatever the 0 bit, that is a stuff bit, and we have to discard it. So if we want to convert input from output, it is 0, 1, 2, 3, 4, 5, and then ignore this 0, 0, 1, 0, 1. This will be our answer. You can check accordingly in which option it is there. So here we have tried to cover few questions from the GATE previous year accordingly, and we have selected it, and then I have tried and covered it. Few students are asking for the QR code. So you can find out that I think this is the my Telegram channel name. You can find it out accordingly. CSPW. Here you can find it out, my details. I'll upload the PDF in the group also, this PDF, or you can find it in the app also. I'll upload in the group. Fine, you can collect it from here. So next class timing is 7 p.m. where there is a Maha Abhyas session. We will cover few more questions which I have prepared. So now I have to take break, and then again 7 o'clock we have to 7 p.m. we have to attend the session, but that is in GATE wala CS channel, Hinglish channel, not in English channel. Clear? So here one query is that Jyoti Radit is saying that sir evening में poll मत रखिएगा, बहुत टाइम कंज्यूम होता है, एंड प्लीज और न्यूमेरिकल प्रैक्टिस करवाइएगा. थैंक यू फॉर दिस ग्रेट सेशन. थैंक्स फॉर योर, आपका रिकॉर्ड टूटने से हाफ और रह गया. Actually the one more session is there, so I have to ready for that also. Then and we are going to end this session. So thank you everyone. Thank you. Then yeah, Ravi Shinde, my record is already broken. Yesterday I have taken more than 4 hours class in the night. After the dinner, non-stop we have taken the class. I have not taken any break in between them. Okay. Arti Matri, thank you everyone.